Hi everyone, welcome to Chemistry. Thermodynamics part 4. In part 1, I have discussed about the types of the systems. In part 2, intensive and extensive properties. In part 3, questions of types of systems. Now in part 4, process, types of process and what is process. Next, state and path functions, right? So first of all, we have so many types of processes are there. Isothermal process, isobaric process, isochoric process, cyclic process, adiabatic process and everything. So before we discuss about these kind of processes, first of all we have to discuss about what is process. That's the point. So first of all I'm going to discuss about the process, right? First of all, simple, I'm here, right? I am at this state. Now you are applying some force on me. So whenever you apply some force on me like this, now I'm moving to this position. Now my state has been changed, right? So on applying some operation, if system state will change, that is called process. What is process? So the process is nothing but if state of system changes, on applying some operation is called process, right? Now during this process anything might happen, right? First suppose I am at the initial state here. On applying some force I am moving to this position. Now my temperature might change, my pressure might change, my volume might change, my internal energy might change. Internal energy and change in enthalpy definitely will change when state of the system changes, right? So any variable might change, might not change. Okay, so depending on this we have different kind of systems. That means during this process delta U not equal to 0, the change in internal energy might not change, might change, right? So initially you have internal energy for suppose 25 kilojoule per mole. After that 50 kilojoule per mole. There is a difference, delta U 50 minus 25. So delta U not equal to 0, delta H not equal to 0, delta T not equal to 0, delta P not equal to 0, delta V not equal to 0. They might anything, right? So anything can change, anything might not change. This is about the process. Okay, it's okay. Now we have an idea about the process. I hope you people know what's the system. Any specific portion of universe. I have already discussed about this in my first video. Okay, so anything you take, if you consider me as a system, except me, everything is surrounding. If you consider board as a system, except board, everything is surrounding, right? Okay, now depending upon this process, we have this process. In this process we have isothermal process. First of all, the first one is isothermal process. Second isobaric process. Third, isochoric process. Fourth, adiabatic process. Fifth, cyclic process. Sixth, reversible process. And seventh, irreversible process. Right? Okay. Now I'm taking one container here. I'm taking one container here. In this container I have one gas. Gas molecules are there here, right? Gas molecules are there here. Now this is the system. In container, this gas molecules, this gas is nothing but my system. Okay, now what happens? I'm applying some pressure on this from the surrounding. That means I'm applying some external pressure on this system, right? I'm applying some external pressure. That means I'm doing some operation. I'm applying some external pressure from the surrounding. Already gas has some pressure, internal pressure. Gas has some pressure, internal pressure, right? P gas, pressure of the gas. Okay. Now when I'm applying some force or some pressure from the surroundings, what happens? This system state is changing. How? Because if external pressure is greater than internal pressure, compression takes place. Here initially the gas is at this level. Now my gas is at this level because of external pressure. Now my gas is at this level, right? My gas is at this level. Right? Now pressure has been changed. Initially pressure, when I'm applying pressure from the outer side, gas molecules are come closer to each other, so pressure is increasing, volume you can see decreasing, but I'm here fixed the temperature. For suppose this system is at the 25 degrees Celsius, this system is also at the 25 degrees Celsius, right? Now temperature of the system has not been changed. Has not been changed. That means temperature is constant. Here temperature is 25, here temperature is 25. So delta T, 25 minus 25, 0. So at isothermal process, delta T equal to 0. Pressure might change, volume might change. Generally in thermodynamics, we generally talk about temperature, pressure and volume variables mostly. So pressure might change, volume might change, but the system temperature is not changing. So the change in temperature of the system is 0. So this is called isothermal. Iso means constant. So temperature is constant. Temperature here 25. So after applying some operation, applying some pressure, now this system temperature is also 25. So temperature is not changing, temperature is constant. So this is isothermal process. So in isothermal process, delta T equal to 0, I can say T equal to 0 and delta T is also 0. Okay, clear? Now again, for suppose I'm taking the same system here. What is isobaric? Isobaric process means pressure is constant. I'm not applying any pressure from the outer side. Now I fixed the pressure of the system. So even on doing something on the system, even after performing something on the system, even after some operation, pressure is constant. Volume might change, temperature might change, internal energy of the system might change. Any variable can change. Any variable of the system can change, but pressure is not changing. Then in that case, pressure is not changing. Here pressure is 1 atmospheric pressure. Here pressure is 1 atmospheric pressure. Delta P 1 minus 1, 0. So in this case, in isobaric process, delta P equal to 0. Delta P equal to 0, P equal to constant. Pressure of the system is constant. Here T is constant. Okay. Here T is constant. Here pressure is constant. Delta P equal to 0. In the same way, isochoric process. Now I'm fixing the volume, not pressure and temperature. Okay. So here the volume, for suppose you take 5 liters. Here after applying some operation on this, now this system volume is also 5 liters. So volume is constant, So delta V, 5 minus 5, 0. So delta V equal to 0, that is called isochoric process. So V equal to constant, delta V equal to 0, that is isochoric process. So conclusion is iso means constant. First of all, iso means constant. Process is nothing but after applying some operation, if state of the system will change, then that is nothing but process. So in isothermal process, temperature is constant. Temperature is constant, delta T equal to 0. This is the conclusion. In isobaric process, pressure is constant, delta P equal to 0. In isochoric process, volume is constant, delta V equal to 0. Clear? Okay. Now isothermal, isobaric, isochoric, these three completed. Okay. Now if you observe what is adiabatic process and what is cyclic process, देखो, again I am taking this container, so here gas, this is the gas. Now I am applying some pressure, that means I am applying some operation. Now my gas is like this. Now my gas is like this. So because of compression, now my gas is at this level. Now my gas is at this level, right? Now my gas is at this level. So after applying some operation, during this process, I discussed about the boundary, insulator boundary and conductor boundary. It is just like isolated system. In isolated system, you know, heat cannot exchange between the system and surrounding. Why? Because of adiabatic walls, because of the insulator. Conductor can transfer heat from the system to the surroundings, but if you have the insulator boundary, this insulator boundary, heat cannot transfer from system to the surroundings. So during this process, the process in which the heat cannot transfer between the system and the surrounding, okay, even you apply some operation on the system, so here the state has been changing, but in this case, during this process, heat cannot exchange between the system and the surrounding. That is called adiabatic process. Whenever heat is not exchanging, my Q, heat, equal to 0, because in this process is being done, but heat cannot exchange between the system and surrounding, so heat equal to 0. So in adiabatic process, Q equal to 0. Okay, so this is about the adiabatic process. Next, cyclic process. In the cyclic process, the state of the system remains constant. The process in which the state of the system remains constant. So what is this? Simple. For suppose you are at the position A. This is your state initially. In all the process you have seen, initial and final states are not same after applying some operation. Now you are at the initial state. Now you are going to your office. First of all, you are going to your, for suppose, food park. Then you are going to your gym. You are going to your office. Then you are coming back to your home. Now your state, your initial state, again you are coming to your home, right? So you are getting back to your home. That means your initial state and final state is same here. Your initial state is equal to the final state. So whenever your initial state and final state, initially at the initial state you have, for suppose, 5 kilojoule per mole internal energy. Again at the final state also, now you have 5 kilojoule per mole internal energy. So internal energy of the system does not change. In the same way, delta H will also not change. So whenever we have the cyclic process, initial state is equal to final state. So the state of the system does not change. In this process, cyclic process, delta U equal to 0 and delta H equal to 0. Right? Delta U equal to 0, delta H equal to 0. Okay. Next, after cyclic process. So these are the types of processes. So after this, we have reversible process and irreversible process. Reversible process and irreversible process. So what is irreversible and what is reversible? First of all, here I am writing irreversible process. Irreversible process. Here I am writing reversible process. Okay, here irreversible process, here's reversible process. Simple. Irreversible process will complete in one step, or we can say finite step. For suppose, what is this? I'm having gas here, right? I'm having gas here. Gas particles are there here. Now, I'm performing some operation on this. That is nothing but your process. So I'm applying some pressure, external pressure. Initially, gas have some pressure, internal pressure, P gas. Whenever we have the irreversible process, external pressure which is not equal to internal pressure, right? So here two conditions. One condition is external pressure might greater than internal pressure, or P external less than pressure of the gas. Okay, so whenever you have more external pressure, what will happen? Whenever you have more external pressure, what will happen? You have more external pressure from the surroundings than the pressure of the gas. Then whenever you are applying the force, volume of the gas decreases, pressure of the gas increases. That is nothing but your compression. Volume of the gas decreases. That is nothing but your compression. So here the compression takes place. Okay, so whenever P external is less than pressure of the gas, means from the bottom internal pressure is higher than external pressure, so that volume of the gas will increase. Volume of the gas will increase. That is nothing but your expansion. So whenever you have external pressure is greater than pressure of the gas. Okay, clear or not? See, whenever this external pressure is high, my container is like this. Okay, now gas is at this level. Now my gas is at this level. So this is external pressure is greater than internal pressure. So this is called compression. Now whenever external pressure is less than pressure of the gas, this is nothing but your expansion. Volume of the gas will increase. So now my gas is at this level. Okay, compared to this volume is high, so this is nothing but your expansion. Okay, so compression and expansion. So this process will take place in finite steps and finite time, right? So this is called irreversible process. So this irreversible process is a real process. This irreversible process is a real process, and it is a directional process. Why? Because it is in a single direction. This process has been done. So this irreversible process is a this process is a very reversible process. Now what happens here? External pressure is greater than pressure of the gas. That means delta P. So there is a change, right? There is a change. Delta P equal to external pressure minus pressure of the gas. That means there is a change. So delta P not equal to 0. External pressure which is not equal to pressure of the gas. So delta P not equal to 0 in irreversible process. But when I take reversible process, what happens? When I take reversible process, this will take finite steps. Okay, this will take finite steps. For suppose I have the gas here. So what happens here is I am applying some external pressure from me. So internal pressure of the gas is also there, right? So external pressure at this reversible process, external pressure is almost equal to pressure of the gas. Okay, just listen. I'm here. Okay, you are applying 1 atmosphere for suppose force or energy, 5 kilojoule per mole energy on me. Okay, you are applying 5 kilojoule per mole energy on me. Now I am moving like this. Okay, so again, okay, if I apply 5 for suppose I am here, right? If I am applying 5 kilojoule per mole energy on you, again you are applying 4.9 kilojoule per mole energy on me. Okay, my state has not been changing. My state is not changing that much. Okay, there is very negligible difference. For suppose, I will explain you clearly. Here external pressure, for suppose, see here external pressure, for suppose 5 atmospheric pressure. Okay, from the surrounding we are applying 5 atmospheric pressure. Okay, so now my internal pressure is 4.9 atmospheric pressure. 4.9 atmospheric pressure. That means delta P is negligible. Delta P equal to P external minus P gas. That means 5 minus 4.9. That means 0.1 approximately. That means delta P here is almost tends to 0. Almost tends to 0. So to complete this process, it will take infinite steps because of negligible change. It will take infinite steps, infinite time. So this is called reversible process. If you observe here, I am applying some force or pressure from the surrounding. In the same way, same amount of pressure is generating from the system too. That means system and surrounding are in equilibrium. So in reversible process, system and surrounding are in equilibrium. So this is called reversible process. So now I'm writing the points, very important points. Just remember here. First of all, irreversible process, and here reversible process. So the first point, delta P equal to external pressure minus pressure of the gas, and here delta P not equal to 0. Okay, now second point, it will take finite steps, or a single step we can say, finite steps and finite time. Third one, it is a real process. It is a real process, and all natural process are this irreversible process. Last one, it is directional, single direction. Okay, so there is no other force from the inside here. Okay, if you have the if you are applying pressure from the outer side, it is only single direction, or if you are applying pressure from the inside only, that is also single direction. So it is single direction. Here delta P equal to 0, delta P equal to 0. It will take infinite steps and time, Okay, next, it is hypothetical process. Hypothetical process, or we can say theoretical process. And very important point, in this reversible process, system and surroundings are in equilibrium. System and surroundings are in equilibrium, right? So this is about the irreversible process and reversible process, right? I hope you people clear now. Okay, so simple reversible process will take infinite time to complete. Irreversible process will take finite time, very less time to complete. Okay, so this is about the reversible process and irreversible process. Next, state function and path function. Very easy. The function which depends upon the initial and final state, that is called state function, right? The function which depends on path, that is called path function. Okay, so I will explain about this state function and path function in my next video. Okay, so that's all for this video. Thank you so much for watching, and yeah, that's all. Have a nice day. Bye bye.